considering integration using trigonometric substitution. Now let's consider using x is equals to a sine theta substitution in this format of integral of 1 over square root of a squared minus x squared. Now, given that x is equals to a sine theta, therefore the x d theta is equals to a cos theta. Now, if the x d theta is equals to a cos theta, then we can make the x equal to formula, which should be a cos theta d theta. Now, just as we're doing in substitution, now let's change this variable from x to theta. So this becomes 1 divided by square root of a squared, and wherever we see x, we'll put a sine theta squared, and our dx is now a cos theta d theta. Therefore, this becomes integral of 1 over square root of a squared minus a squared sine squared theta multiplied by a cos theta d theta. Now let's factorize the denominator with a squared. Then we have 1 minus sine squared theta, and the numerator will now be a cos theta d theta. Now in trigonometric identities, we know that cos squared theta plus sine squared theta is equals to 1. Therefore, cos squared theta is equals to 1 minus sine squared theta. So this can be, cos squared theta can be written as 1 minus sine squared theta. So this becomes 4 cos theta divided by square root of a squared cos squared theta d theta. Now this is equal to integral of a cos theta divided by square root of a squared cos squared theta is a cos theta d theta. Now this is equal to integral of 1 d theta. Now integrating a constant, we will have theta plus c. Now what is theta? Remember, we are using the substitution of x is equals to a sine theta. So if x is equals to a sine theta, therefore theta is equals to arc sine x over a. Therefore, integral of 1 over square root of a squared minus x squared dx is equal to arc sine x over a plus c. Now, understanding this principle will help us in solving questions in this manner. Let's take for instance, let us evaluate the integral of 1 over square root of 9 minus x squared dx. Now we know that 9 is 3 squared. So this is similar to saying integral of 1 over square root of 3 squared minus x squared dx. Therefore, if you compare this to this, we will see that a is equal to 3. Therefore, our answer is equal to arc sine x over 3, because we are saying arc sine x over a, and a is equals to 3 plus c. So the answer of this is simply arc sine x over 3 plus c. Now what if we have an upper limit or lower limit in this case? So let's say 0, 3, okay, 1 over square root of 9 minus x squared with respect to x. We know that after we integrate 1 over square root of 9 minus x squared, our answer is arc sine x over 3. And now, since we are now dealing with definite integral, there will be no need for constant of integration c, but we'll have upper limits and lower limits of 3 and 0. Therefore, we apply our upper limit, that will be arc sine into 3 over 3 minus our lower limit, that is arc sine 0 over 3. Now this is arc sine 1 minus arc sine 0. And plotting it into our calculator, we will have pi over 2. Arc sine of 0 is 0. So the answer is pi over 2. Let's take another example. We're given to determine the integral of 5 divided by square root of 4 minus t squared dt. Now this can be written again as 5 being a constant, 1 over square root of 4 minus t squared dt. Now we can see that this form here is related to the form that we are dealing with. That is 1 over square root of a squared minus x squared. Now, putting this in this form, in the term a squared minus x squared dx, we realize that this becomes 5 integral of 1 over 2 squared minus t squared dt. Now, when we compare this with what we have here, we realize that a is equals to 2. Now, if a is equals to 2, then what is the answer? Since the integral of this format is equal to arc sine x over a plus c, therefore the answer here becomes 5 multiplied by arc sine. The variable here is t, and a is what? 2 plus c. So which gives us 5 arc sine t over 2 plus c. In our next video, we'll be taking a look at how to integrate the form integral of square root of a squared minus x squared with respect to x.